Station screen, so we can all be looking at the same thing. So I'm just gonna go like frame by frame. Each group, just tell me which, if you want the first or the second picture, right? And just feel free to present whatever you have. So, Geo, Reed, Ronan, do you want number 2 or number 3? Number 2, says Geo. Then you have the floor.
I can start. So the system right here on the top left, we just did the ball and the moon's gravitational force, and we know the system is isolated because nothing else in the schema is touching the system.
That's awesome. Love it.
Okay, so then if we go down to the graph in the lower left, the system shape stays unchanged throughout the entire process. The temperature as well, and the speed also stays unchanged. So that means, yeah, everything is the same.
Got it. Geo, just for like, again, like if we reserve unchanged for a comparison.
Yeah,
right?
yeah, I know.
How would you describe the process if you didn't use unchanged? Like, what you're trying to do, like I understand what you're trying to say, but like if you wanted to do something different than unchanged, what would you describe it as?
I guess the ball, like, in the air.
Yeah, or right above your hand.
Yeah.
Right? Because that's the thing that matters, right? It's like it's right above your hand.
Mm-hmm.
And then at the end, it's right above your hand. So
yeah,
not changed. Like that's the thing that we're trying to tell the reader, is that at the beginning it was before your hand, at the end it was before your hand. And agree.
And then at the end, we can see the LOL diagram kind of just matches the graph or the chart, sorry.
Totally.
And yeah, like everything stays unchanged because it's like the same, like the start and the end are practically the same, except one, like the speed is going up and one going down, but it's like the same speed. Yeah.
And how do you know that it has to be the same speed?
I mean, because like the whole system is isolated, so like the numbers have to stay the same, and I think like all the other types of energy stayed the same, so it has like the speed has to stay the same, or the kinetic energy.
I love the representation of EPGF with a 0 there. It's very clever. I wonder who taught you that and do that one. Okay. Okay, next group then. That would be Ellie, Leah, Marlo, and Layla. 2 or 3?
We're on the next one.
The next one, of course. There you are.
Okay, so you can see our schema is just the ball and the moon's gravity field with the system boundary around both. And we said that we know the system is isolated because everything in the schema is within the system boundary.
Excellent.
And then if you look over at the chart, our process start was the moment that tennis ball left the hand that threw it up, and the end was just before it was about to hit the ground. So the system shape, when we first threw it up, it was much further from the ground than the process end. So we said further from the ground for the process start, and closer to further from the moon and closer to the moon for the process end. And then for the system temperature, we think that stayed the same. So it's just a T in each. And then the system speed, as it was thrown up, we think it was slower. And as it was going towards the ground, we think it got faster. So the change in properties, the system shape changed. And so we think that there is less the EPGF. And then the system temperature stayed the same. So the ETH stays the same. And then the system speed got faster. So now the EK got bigger.
Got it. How did you know that the temperature stayed the same?
Because there was no air on the moon. Like normally if you threw a tennis ball on Earth, there'd be a little bit of air resistance and drag on the ball, which would slightly which would slightly lower the temperature.
Mhm.
But since there's no air, then that didn't happen.
Love it. Ali, anything you want to add?
Yeah, as for like the LOL diagrams, we know that there's like a conservation of energy because while the type of energy changes, there's still the same amount since the system is isolated.
Awesome. Cool. That is beautiful. That is a great answer. Very complete. Dak and Ollie, 2 or 3?
We're gonna go with 3.
You're gonna go with 3. Field.
All right. I can start us out. I'll talk about the table. So for the shape, at the start, the ball is higher, and then the end, the ball's lower because the ball's, almost on the surface. And the system does change shape. And there is a change in energy there. For the temperature, it stays constant throughout the whole thing. And then for the speed increases at the end. I think that's pretty much it for the table.
For the schema, we know that that the system is isolated because the only two things in the schema are the ball and the moon's gravitational field, and those are both in the system. So.
And for the LOL diagram, we know the temperature stays the same because there's no air. And we know it starts off with a lot of potential energy, but as the ball starts coming down, it turns into kinetic energy. So that's why there's more kinetic at the second diagram.
Love it. Love it. Great job. Group 5, Casper, Jordan, and Mark. 2 or 3?
3, please. Or 3, yeah, sorry.
So the for the schema, we just had the ball in the moon's gravitational field because it was started at the moment it left the hand. So the hand was pre-system. And for the table, we had the shape as being a slight change. You can see we have the moon with the little point of the tennis ball on top, and then we have a less visible tennis ball, or actually invisible tennis ball on the bottom. And so we believe that it did slightly change shape. And the temperature we believe stayed the same because there's not much friction from the atmosphere, at least not enough to create a significant amount of temperature. But we believe it did speed up, even if by a little bit, because its ending distance relatively was closer to the gravitational field. Hence, the gravitational field would affect it more, creating more speed.
Got it.
Yeah. And we said yes for B, that the system is isolated because there are no interactions between anything inside the system and anything outside the system during the process of the system. So like there's the hand, but the hand is pre-system. And the moon's...
I'm sorry to interrupt. Can you let the rest of your group talk a little bit?
Oh no, he was going to talk about the LOL diagram and the E.
Jordan's not here, seems like.
Yeah, Jordan's not here, so...
I apologize for interrupting. That was rude on my part.
Okay, so for B, I said that yes, the system is isolated because there's nothing that there's no interactions between anything inside the system like the ball and anything outside the system like, I don't know, the moon, the physical moon. That's post-system and the hand is pre-system, so yeah.
And then for the LOL diagram, we have 6 blocks in total. So that means that at first the kinetic energy was at 2 blocks, and then we moved it up to 4 blocks because the EPGF went down because it was almost at the ground.
Got it. So one, again, and my apologies for interrupting. I just want to make sure that everybody had a chance to say. I love your answer. It's great. I would say don't be shy like when we do representations, graphical representations, don't be shy. Think of them more as caricature as they are like artistic renditions of what's going on. So like the whole like idea of that you can represent the ball by like this little tiny dot on top of this enormous moon, like just make two balls far apart. You can even give them the same size if you want to, like it really doesn't matter. Like make them far apart and make them closer, right? Like, so, because the point is to convince the reader that that is what's going on. Like there's no way, I didn't see the little dot at the beginning, and so it was just really like, wonder what's going on. Okay, so just like caricature, but that was great, good answer. Next group, Noel, Ruby, and Ian, 2 or 3?
2.
2, well there you are then.
So for the schema, our drawing shows that the system is isolated because there are no arrows connecting the system to anything outside the system, as shown by the system boundary. And the only two things in it are the tennis ball and the moon's gravitational field.
Okay.
And then for sorry, and then for the table, the system shape was not changed, and the system temperature stayed just normal at the start and then got higher, and the system speed I forget what that means. Okay, but moving wait what does the V mean?
Velocity, right? I'm assuming.
Yeah, I forget the can my group please help me out? Sorry.
The speed stays the same at the beginning and the end.
Mm-hmm.
And and then for the energy, the potential energy doesn't change, the thermal energy does change, and the speed doesn't change. And then the diagram, like it says that the potential energy doesn't change, the thermal energy gets higher, and then the kinetic energy stays the same.
Okay, thank you for that. That was super clear. Any reaction to this particular whiteboard from the rest of the group? Casper?
I noticed that the system temperature got higher, but since it was on the moon, there's no air for the ball to be frictioned on, so it shouldn't get higher, it should stay the same.
So that's one way to attack the problem. You could say, hey, I know something about the physics of the moon. There's no atmosphere, and therefore there's no drag, and therefore there's no way for the temperature to get hotter. Let's say, for example, you know nothing about the moon, right? You know nothing about the moon. Or maybe you were doing this as a black hole and you have no idea whether there's an atmosphere in a black hole, right? Can somebody look at the energy diagram, the LOL diagram, and tell me why, based on our system schema, it could not be right? Gio.
Well, if the system is isolated, then the energy should like stay the same. So if at the beginning there's like 4 boxes, there should be 4 boxes at the end as well.
Exactly, right? So even if you knew nothing about the atmosphere on the moon, the fact that the system is isolated, as described in the schema, means that the energy at the beginning and at the end have to be the same. And this is why it's so important to represent the schema and so important to represent the boundary, because that is completely going to determine your conversation about the LOL diagram, right? And let's see, I think that's it. I think we're done. You have